Hi, I'm Michael Goldwasser. One of the wonderful things about bringing our data structures and algorithms titles into the Xi platform is that the Xi platform is so engaging and interactive. Visuals are hugely important when you're learning data structures. I think the visuals of our original book were a real asset, but we have taken it to a whole new level now that we're in the platform. As a side-by-side, here is a page from one of our original figures. And this happens to be skip list. We're showing an insertion of a new item. So it's the search down to find where to put the new item and then building the tower up. And we do hope that in the static version of this in print that students could follow along and understand what was going on. But as we bring this into the Xi platform, we really do get to animate it, that we can show here's the search as we're going down looking for where 42 should be placed. And then once we figure out it's between 39 and 44, we can go ahead and make a new tower that's starting there. And then we can expand the tower higher to other levels and show how it gets spliced in as we're going forward. In our print book, there were a lot of times where, in fact, we would devote full pages or sometimes several pages to these step by step. So in this case, we're removing the minimum from a heap, replacing it with the last element and down heaping. And so we were trying to get the students understand step by step, here's what happens, and then this happens and so forth. But again, in an animated version, we can now really do that step by step with captions, let students go at their own pace as the minimum value is pulled out, as we highlight that the last value 70 is the one that's going to be moved up to the root, as we then go through the step that we've got a down heap, so 70 and 25 are going to swap, 70 and 41 are going to swap to get that back into place. Code is also very important for us. So here's again a page from our original book. This is the recursive implementation of binary search. And then right below that, we have a figure of showing essentially the steps of the recursion on an example. And by having these side by side in the book, our hope was that students could kind of see how the code is working. To realize when you start with these parameters, you calculate the mid, that lets you build a recursion, in this case on the right side and so forth. And hopefully even with the static image that they could see, oh, I see what's going on. But again, we have new opportunities here that in our version of it on the Xi platform, we can again show the code and show this, but really go step by step as a code trace. We can show the initial call, what the parameters were, go through and watch the code step through, checking if it's a base case. When it's not a base case, it computes the mid, figures out what that mid should be. Again, the next step is to compare the target 11 to the mid value 17, checking whether they're equal or whether the target is less than or greater than. In this case, since it's less than, we start a new recursive call. That comes back to the top. And again, as students want to step through this, they could go through and hopefully, again, see that final picture that we were building in the print version of this, but to see how it's built and to be able to connect it as we're going through. The other aspect is it's not just that we have animations, but we can engage students by asking them questions. So another topic from the book here is tree traversals. This is a pre-order tree traversal. And again, for anybody who knows this topic, you want the students to be able to start to get used to this idea of how the recursion goes through a traversal of a tree and the order in which things get reported as we're going forward. And again, here we can do the animated version and say, well, it's first the root, and then the left child of the root, and then the left child of that, to again animate as you bottom out the recursions, that some recursions end and new recursions start. And again, this recursion will end up bottoming out and will come all the way back to the root and the second child of the root and then the third child of the root. And so we have this animation that students can control to be able to see how to build this. But once they're done with this, directly in the same thing is we now get to go and ask them questions. And there are different question types that the platform supports that allow different levels of learning as we're going forward. So we're going to start with a multiple choice question, say, here's a tree, here are your choices, which one do you think is pre-order? And again, this is set up so that if they do make a mistake, we can give a little bit of feedback of what should happen and what might have gone wrong and customize the message to that. And if they get it right, we can hopefully explain that's the case. But we can also do different styles. So here's a matching style. We have 3 different trees. These are the pre-order traversals of those trees, but not necessarily in the correct order. And they need to figure out which of these is tree 1, tree 2, and tree 3. So for instance, Tree 3 is A, B, D, E, C, F, which is this one. And again, they could go through and try to fetch that. We can dig a little bit deeper. So we kind of scaffolded a bit for those first ones, but now we can give a fill in the blank where they actually just have to type it. We're not giving them choices, but they have to be able to go through and figure out from this tree how to get hopefully the right answer. But again, if they make a mistake, we can give a little bit of a hint as we're going forward. So these are great ideas. We can use these in a lot of different ways. If you've got more time, there's also some coding examples as well. So we've got a platform here where we're having them replace a for loop with a while loop to see how you can do the equivalence. And again, they can go through, we can give them some scaffolded code, and then they can go through and try to rearrange this called the Parsons problem, where we're giving them different parts of code as they're going forward. And as they draw this in different ways, they can go ahead and check. Now, in some cases, it might not compile. So again, right now, it's going to complain that I don't have a return statement. And so this won't even compile. If I went ahead and put a return statement in, this is still not the correct code, but the platform allows you to go through test cases that we defined as authors and be able to say, well, when the input was 5, you outputted 0, but you should have outputted 55 and so forth. And they can again go back and hopefully try to go through and fix and figure out how to get through and retest as they're going. So there's a lot of exciting ideas. I hope that you get a chance to explore this yourself, and I hope your students do as well. Thank you.